All right. Today is another webinar here. This is the third webinar. We are going to be looking at, or I should say fourth, the coding on our Arduino. We're looking at finishing up multiple LEDs, or at least get going on it. You did 2 LEDs last time. This will go into, well, what do we want to do if we want to do more than 1 LED? So the focus on this next 2 webinars is still a lot on programming, but then after that, it's really more on the hardware. Okay? So, and we'll have as many of these as we need to have to get you everybody ready. I will also do a webinar that will talk just about what the competition is going to be like. We'll do that before the Raleigh. I think the first science competition is then. Okay? And so, there we go. All right? Okay. Now, we got everything? All right, good. So, it's recording right now. We learned that if you want to do multiple pins, that you're going to end up repeating the line of code. So, if you define this pin, LED pin 1 is 9, LED pin 2 is 10. We use the variables because I can change these 2 pins, these numbers here, and it impacts the whole program, as opposed to having to type it out in each spot. So down here, we look at the pin mode. That's a function. So we go into void setup. Remember, these are variables defined out here, so they can be seen throughout the program. Then you have void setup, and you need void loop. That is true in any program you use with Arduino code. All right? And so you have pin mode, LED pin 1 output, pin mode, LED P2 output. So again, you're saying, hey, pin number 9, that variable, making an output. It could be an input, it could be an output. All we've really talked about is output so far. Sorry about that. My mouse button went a little bit. Then down here, you say write 1 high, write the second one high. Wait a second, write 1 low, write the second one low. And you delay a second. You've got to have these delays. If you turn these on and immediately turn them off, they'll always look off. And that's what that / is giving you a comment. Any questions about this part of code? I purposely went kind of quickly so we can get rolling on this. All right. Can you do this? Did you do this last time? Did you do an out traffic light? Raise your hand if you did a traffic light, or send me a letter, it's a question saying, no, we did not work on a traffic light. I just want to make sure I wasn't giving his homework or something. Okay. Nobody's saying not so. All right. What I would really highly we did not do a traffic light. That's what I thought. I didn't remember seeing the notes. So Daniel, and I would tell everybody else, for practice tonight, then we get back next Monday, do a traffic light. And I'll go through the code with you. If we get so far today, I may even show you. You don't have to do any looping or anything, but basically think about a traffic light. And you can use different LEDs. The color of the LED doesn't matter, but what do you think about it? If you're driving, if you're at the light or red light, you stop for 4 seconds. The car is going the other way, therefore must be traveling at 4 seconds. But they're not going at full speed the whole time. They're going 3 seconds normal speed, green, 1 second at yellow, that adds up to 4, the same length of time as the stoplight in this case. So see if you can do that. I'm just going to flash by this real quick hint. It's going to be just looking at turning different ones on and off. Now, let's talk about if we want to do multiple LEDs. I'm going to put everybody's hands down, actually. Raise your hand if you have your Arduino kit near you. Good. It really is helpful, folks, if you have the kits near you. I can't stress it enough. See if your teacher will let you borrow a little bit of one, or go ahead and go to circuit 123D for what we're going to about to do in a minute. Okay? Now, so this adds some advanced techniques, okay? So it's going to be some complicated programming to begin with. Let me ask you this. If you've never programmed before, if you've programmed before, just some of the stuff will be pretty straightforward. Raise your hand if you've programmed before. Great. Excellent. All right, we got a bunch of programmers here. So you don't have to be a programmer, but it's helpful. I put everybody's hands down. Go ahead. Could you raise your hand again? I didn't mean to lower your hands. I just wanted to see who all had it. Raise your hands if you programmed. Totally fine if you haven't, but let's see. Okay, I would say we have half of us. All right. Well, again, this is being recorded. I'll have it later. Try to do this at school or try to do it with 1, 2, 3D circuit. Okay? So, with that in mind, let's go down to this next line. And I'm going to go ahead and I'll make it so this screen is bigger so it makes more sense. Adding multiple LEDs involves a few advanced techniques. No big deal. We can get there. So this is how you would hook it up. Just to give you a sense, you're hooking up LEDs to every one of these pins. Pin 2, 3, 4, 5, 6, 7, 8, 9. They're going through a resistor back into a ground. So they're taking the resistors going into the ground. The hot goes in from pin 9. Remember, LEDs are very sensitive. Okay? So think about it. Here's what's happening. So from pin 3, we're going to follow this purple line across. It's going to come in on one side of the LED, the anode side. The cathode side is going to this resistor that's hooked along this ground here. So that's why they're saying that. They're saying, hey, you go from pin, positive side to anode side of the LED, and then you go to the cathode, which goes right into the ground. Now you might say to yourself, why don't I just use one resistor? Then they'll all get the use of that resistor. Because it gets in the concept of power. And those resistors are only rated for so much power. And if it's drawing all this current through them, and with the one ground, you're going to probably burn up your resistor. What will happen is the resistor will go off. You probably get a little smoke smell. The lights will suddenly get bright, and then they're going to go off because you just fried your LEDs. Don't worry, if you put the 330 in, you can't. Just make sure you don't do them separately. And this is how it actually looks out. Positives going back to the pins, so we can make those all output pins, right? And then resistors are going right into the ground. It's not the only way you can do it, but there we have it. As long as you only turned off one LED at a time, could you just use one resistor? As long as you turned on one LED at a time, possibly, yes. But that would defeat the fun of having LEDs. You're certainly going to want to have multiple LEDs. You'd be limited. Okay? All right, now, and you could do this. Okay? Now, what I would really like you to do for a few minutes is let's try to get that hooked up. Okay? Let's try real quickly. Go to 1, 2, 3D circuit. If you don't have the pen, try to hook these things up for a second. Even if you don't get all the LEDs hooked up, get some of them so then you come back later and practice with this. All right? We're going to go through 2 through 9 there. Get to 2, 3, 4, 5 if you want, but try to get some of them hooked up. I'll give you a few moments to do that. I'm going to pause. I'll just let the recording go. Sometimes they'll come back on. Let's take a couple minutes to do that. I'm going to give you a couple minutes here. I'm going to put everybody's hands down. Raise them when you get raise them when you get 3 or 4 of these LEDs hooked up. Don't worry. I'm going to show you with them all, but what we're saying would apply. You go into 1, 2, 3D circuit, use Chrome if you're doing that, and see if you can drag and pull a couple up. We won't take a lot of time. I just want to see if you can get a couple of them going, folks. It's so much better if you can write code. I really believe just lecturing in this is terrible. If we could physically all get together, I would be handing you components and having you to push them in together and have you do them. But this is much more, I think that's a better way to learn. This is a much more efficient way to get the word out to a bunch of people. A couple of people are cruising along. Come on, everybody else. All right, we've got Sarah's gotten it, Megan's gotten it, good job. Christopher's gotten it. Arinda's gotten it. Probably just said that wrong, murdered her name. I'm surprised. Ananda. I'm sorry. All right. Now, okay, we've got enough people that we can keep pressing. We've got to go and get programming on this. So, with that in mind, go to the next slide here. That's the color chart we're not going to worry about. Okay, again, we only had 2 LEDs. We would just copy. We have 1 LED, then every second LED, we'd have an output. We turn one on high, the next one high, one on low. And then this happens so fast to your eye, both those come on instantly. To our eye, appears that way. That would be a problem with 9 pins, 8 pins, 2, 3, 4, 5, 6, 7, 8, 9. That's 8 pins. You could do it, but we would say the code isn't very efficient, not very elegant. So what we would want to do is looping. I'll put a hands down here to ask another question. How many of you all done Scratch? Raise your hand if you've ever done Scratch. Interesting. Nobody's done Scratch. Really? Well, that's next example really is going to tell you too much. I'm assuming that we had some people that were used to seeing Scratch. Okay? Well, what we're going to do is a loop. A loop allows us to repeat something, a for loop in particular, for a certain number of times. Whatever's inside the loop, it's going to do it over and over again. So let's look at this loop here. What's ever in between these 2 containers, I call them containers. That's what they act to contain something. All right. And I know curly brackets and all these other names, but really to me, they're containers because they're holding something. And this is going to loop around. Whatever's here, it's going to loop around. So let's look at this. It starts off with 4 space parentheses integer counter. This is defining a variable, and it's starting with the number 0. So we have a variable called counter. In programming, we don't use X and Y, or we've used it very little. We like to call things what they are. A math teacher might say number of apples is X. A programmer would say number of apples is what we're going to call the variable. And I think that really gets yourself that we're very practical. And the reason you get in a habit of doing this is you'll write, I've done this, you'll write code for somebody. They're all thrilled, everybody's happy, go out to lunch, celebrate. 4 months later, you get a call, it's not working right. Better yet, you get a call 6 months later and say, hey, we got some new ideas, we want to make some improvements. You sit back down there and you try to figure out code that isn't well documented. You'll be you'll be very frustrated. All right. So we're going to use this as a counter. So we're going to call that variable counter. For integer counter equals 0. So this is saying create a counter. It's an integer. In other words, whole numbers. Start at 0. And as long as that counter is below 10, do what's inside of here and loop around each time. Notice that says counter plus plus. That's adding 1 to the counter. So it starts off at 0. It says, well, is that less than 10? Yes. Then print this out. Print line 0. And this says add 1 to the counter. Flip up again. Is counter 1 less than 10? Yes, it is. Add it. So it's a way of adding it over and over again. All right? So in this case, count with your finger how many numbers are going to come out of there. Okay, come on, folks. Give me some numbers here. Count with your fingers. We always start, or it's a good practice in programming to start with 0. If you think about it, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 gives you 10 values, right? Because you're starting at 0. It doesn't take up that much space. Whereas if you go to a second digital place, so you go to 11, well, if you had just 1 or 9 or 0, it takes up 1 space. The minute I go to 10, it now takes up 2 spaces. 1, 0. They're in separate spaces. And this is the case all the way up to 99. So we wanted to start in programming at 0 so we don't waste any space. It was a way to save on memory. And it's still good habit. So let's look at this line. Again, let me review with you. If many of you had programming, and show your friends stuff on how a for loop works. Create a variable called counter. Assign it to the value of 0. You know how we go from line to line in this language with a semicolon? You do it there as well. Then you do counter 10 less than 10. You could do counter greater than 10. What I'm saying is, do this as long as the value is less than 10. The minute it's 10, we're going to stop. And this goes counter plus plus, print line, counter. So it's going to print this variable as it's looping through. So how many numbers do you think are going to go out? Ten is exactly right. Well done. Good job. So here's the first thing we can do with a counter to save us a bunch of work. So say we're hooked up from 2 to 9 in terms of pins, and we want to make them all output pins. Remember, Arduinos have those output pins. Let's go back here real quick. You're starting at 2, you're ending at 9. So you've got to make all these outputs. Well, you could do that. Here's a fastest way to do that. 4, integer counter, making a new counter variable. We're going to start at 2. As long as before it gets to 10, go ahead. It's going to do this. All right, until it reaches 10. First time through, it's 2. It comes down here, it says pin mode 2, output. Then it's going to swing through again, add +1 to counter. Counter's now 3. Is that less than 10? Yes, it is. This is 3, comma, output. So the third pin is going to be an output, and so on. What's the highest pin this can go to using this loop that you're going to find as an output with this loop? What's the highest value you can go to? Assuming it's a whole number too, all right? Or an integer. Come on, folks, give me an answer so we can get rolling here. We got a lot to do. Excellent, guys. I didn't say it all. 9. Very good. So you can go up to 9. All right? So you could have done it this way, lame, or you could have done it this way. And this works. This is so much faster. Once you start using loops, you never go back. Okay? Now, let's go ahead. I'm going to show you the start of what we're going to do next. We're going to go ahead and start lighting up some of those LEDs. This is actually very cool when you do it yourself. I build lots of robots, a lot of automated stuff. I still love seeing lots of LEDs go on and off. So, for integer counter equals 2, counter less than 10, counter is now going to be 2. It's going to make an output. Then it's going to come around again. It's going to add 1 to the number 2. So that comes up with 3. Is 3 counter less 3 less than 10? Sure it is. Make counter 3 and output. So forth. So that's we use that in a void setup. In the void loop, we do another counter 2 to 10 again. This time we do write display, write counter high. Wait a second, display right, counter low. So when this loops through, it starts off at 2, goes down display right, 2 is high. Delay a second, display right, counter, which in this case can be 2, is low, delay a second. Loop back up, add 1 to the value, it's 3 now. Display right, 3 as high. Wait a second, display right, 3 as low. Then wait a second. Again, one by one, it's going to keep doing this. I would like everybody take a minute and try to work this out. You don't have to necessarily go to 10. If you only plugged up 5 LEDs, you can. You can go to the other LED. You can go up to 10. It's just you don't have all the LEDs hooked up. I don't want it to cause confusion. Raise your hand once you got a little bit of this code going. Again, you got Arduino, plug it in. If not, do 1, 2, 3 circuit to figure this out. Also, if your team doesn't have anybody that's got any programming experience, see if there's somebody that's taking programming at your school. There's a hotshot coder. See if you can get her to come in and do our Science Olympiad with you. Excellent. Got some people are knocking this thing out. Good job. If there's absolutely no way you can do this, you can't either get 1, 2, 3D circuit to work or whatever, you don't plan on doing it, still raise your hand then if you've already decided it. So we're not waiting for you when you have no intent of doing it. Understand if you can't do it. Understand if you, but we don't want to wait everybody up here. Do a couple more moments and then we'll go on. Any questions? All right, come on, folks. Got a couple more here. Just let us know. Got just about almost everybody on there doing it. Good job. There's always some. And so there you go. Everybody, one more second here. This, to give you an idea, we went from there. Look how much code it is if we did it hard. We didn't use any looping. It's a couple pages here. It's crazy. So you want to use the power of looping. So if we add an additional loop in this, we can turn them all on or all off. Right now, if you do it, you can go up and down. So one thing we don't show it here, it'd still be kind of a cool thing to do if you wanted to, is go 4 integer counter, 2 to counter less than 10. Well, do this. Start at 10 as long as counter is greater than 0. So, well, you could still do less than, I guess. But what you want to do is you can decrease the counter. So you can start at counter 10, or in this case, counter 9, I should say. All right. And then do something about as long as counter is less than 10. In that case, it would be 9. And then be counter minus minus. We would go from largest counter variable to the smallest. So that's one thing. So use counter plus plus. This all saves so much. By using loops and counters, saves you so much code. You know, that is a lot of code. It's 2 pages. This loop does all that 2 pages does. Okay? Any questions? The other thing is, if you're doing 8 pins like here they are, that would get boring after a while. Have to go all the way through that to set them all or change them. So we're going to want to develop some methods to handle that. So in this case, let's do for loops instead. All right. So, and that's what we did. So this one writes it high, waits a second for digital 2 counter less than 10, digital right counter low, delay a second. So we added that additional loop. Okay. Now, here's what it does. Look at this one. 2, everybody loops. In this case, it counts as a higher. This counts as a low. There's a delay. It's the same thing as turn them all on or off. This is a little more elegant code. I'm going to put everybody's hands down at this point. Okay, so you've set your outputs with this loop, and then you've actually turned on your lights. And then you wait a second, you turn them off, right? It's a real time saver to learn how to do that. Well, how do we show them lighting up one after another? Put a little delay in there. Do it now. Get them all to light up. Add a delay between each time it loops through to turn on your light. You'll see a little delay. The light will kind of scream up as opposed to all going on instantly. Great. We got some of you subscribing on YouTube. Good job, folks. So you'll get notifications as I add things on there. So does everybody see how this counter is working? It's going to 2. This counter plus plus increases it, writes it high. Wait a second. 2, counter low. So it would all stream from 2 up, high, and then from 2 off, and 2 up. I'm going to go on to the next thing. You can always come back. I've also given you the PDF of this. After all the pins 2 and 9 are set down, how do we turn off pin 9 and then 8 7s by using this thing? Greater than or equal to. And counter 9. Counter minus, I should say. So watch in this case. For counter 2 less than 10, increased by 1, rated high. For this one, once it goes up high, all the way to the right, if you can imagine all the LEDs are going from left to right, they're all turning on. Then this one would say start at 9 and go down equal to 2 by 1 each time. So it would start from 2 up to 9 bright, and then from 9 back down to 2 low. Okay? So that's a pretty powerful thing to try. Now, we can also do this, and this is where we're going to pick up a little bit right now as we get through this. I want to get through pulse width modulations because these are one of the coolest things you do. An LED, honestly, is either on or off. But your computer has a duty cycle that it actually isn't always on perfect. There's a cycle in it, but it cycles so fast we can't tell the difference with our eyes. Well, if we didn't run that during that cycle, we didn't turn it on the whole time during that cycle. Like we turned it off, part of the cycle, and then turned it back on. Like right here. There's nothing there. There's something here. This looks to our eyes as dimmer compared to this one up here. So we can use that pulse width modulations for LEDs to fade them. We also use run motors, some other things. But you can tell on your red board, there's like this little tilt thing. This is a capable, PWM capable, 5 capable, 6 capable, 9, 10, and 11. All right? So I'm using an Arduino. If the program, I've got a, here we go. We've got the resistors tied into here. These are 330 LEDs. Notice I've been to pin 3, 5, 6, 9, 10, 11. These are all capable now of pulse width modulation. And the reason those is because that's what they decided when they did the board. They didn't do it to all of them. It's to keep price down and costs. So let's start off, and you can go back to 1, 2, 3 the circuit, and you're going to do this. You're going to say pin 3 output. So we're going to turn pin. You can just leave everything hooked up as long as you're hooked up to pin 3. I don't care about the other lights inside it. Go void loop. Pin 3, if you look at it, why is it doing that? Let's go. Pin 3 is tilt, okay? So right from 3 there, it can do this. It can do pulse width modulation. So that's what we want to do here. We're going to have it decrease and decrease, and we're up here. Those are all outputs. Let me go over here. So let's dim 3. So do void setup pin mode 3. You could have made a variable, but since this one was just making the number itself. So connected to pin 3 output. Then under void loop, so that's a PWM cable. You do analog right to pin 3. Remember we made that an output. And you have 255. All right. Wait a second. You go down to 350. and then wait a second. So as you're going to do this, we're going to dim it. And notice we do analog rates, not digital right. Digital right's either 0 or it's 1. Yes or no, true or false. Analog allows you a range of answers. All right? So if you wanted to try that just to see what starts to dim, it's kind of acting more like a digital one right at that moment, but go ahead and do that. I'll give you about 3 minutes to do that, and then we'll go up and do a whole series of them. All right. Let's go on here a little bit more. So that should get you a little bit of a change. But let's even make it look better. Let's have dim 3. So we're going to use loops. So it's going to look like it's sleeping. Like when you have a Mac and you close it and it looks like it's sleeping. Or when your car fades lights on and off. They're using PWM LEDs most likely. So here we go. Void setup. Pin mode 3. That's an output. Void loop. Making a variable. Remember, we use the integers. That's the kind of variable. Start at 0. Go all the way up to less than 256. So the PWM is actually capable from 0 to 255. Increase each one. Analog right 3 counter. So in other words, that value, analog right says go to pin 3, give it a value of 0. Pin 3, make it 1, then 2, then 3, and delay every 5 seconds. So you can slowly see this thing get brighter. And then you do 4 integer counter starting with 255. Greater than equal to 0, count down by -1. Analog right counter, so in this case it'll be 255. Wait 5 seconds, come around, 254. Wait 5 seconds, 5/10, 5/1000th of a second, excuse me. So you want it to slow it down, but it's a very minor slowdown. You couldn't see it with the naked eye normally. Okay? Can I get you all to try this now? Just all you need is one pin working, but try to run this code and run it and watch to see if you can get the LEDs to fade up and down. Raise your hand once you can get it to do this. All right, excellent, guys. That away. Aren't you guys a quick learners. Good job. So we now have the looping up and down. And by the way, this is how we can start to control motors and other things. All right. Also, if you would, try to do this. Hook a pin to pin 2, an LED. That's a digital pin. Keep the existing code for pin 3. That was the analog, right? Yeah, you did. So then what you see here, here's the big difference between analog and digital. In this one, digital, we just say too high. With analog, you've got to give 3 in a value, and this value is going from 0, in this case, to 255. But digital can only be that. Then, for integer counter 255, go down to 0, but here you can say digital write 2 is low. The too high, too low. Analog, we have to give it a different value. What if we wanted to make all the PW breathe? Now we need to talk about something about arrays. Okay? Arrays are just a collection. And if you notice on our looping in the past, we were doing things where we were going to loop every member was going to be an output, right? But is every member a PWM? The action is no. There's 3, there's 5, 6, 9, 10, 11. So we need to be very specific if we want to do those LEDs, all right? So we looked at difference. Now we're going to do, if we want to do them all. Again, if you had Scratch, I could start to show you how we start to use that. Scratch use lists and arrays for those people who are going to admit to doing Scratch. By the way, I teach all my students start off with programming with a little bit of Scratch. Yes, you can start with 3rd graders, but Harvard freshman programming students use Scratch. So don't kid yourself on how powerful. Arrays are a collection of data types, just as we define variables in integer, which we haven't talked about float, but that just says as decimal place, character, strings, those kind of things. Arrays save us from creating lots of different variable names, but more importantly, arrays help us write better code. Each member of an array is identified by what's called an index value, folks, an index value. So if we have an animal as an array, then animal 2 is a member of that array. So you might have animals as an array, and it might be string, animals, because that's what it is, and then a bracket with the size of the members, okay? So let's say this. We have an animal array. Again, we always start with zeros with programming, good habit. So we have an animal array index of 0, that's a cat. Animal index of 1 is the dog. See how I have right there? So let's see, how many animals in this array? Well, I see 7, huh? No, start with that 0. 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. I really should know how to count. I knew the answer to that. So what is an animal 3? Everybody looking at this, tell me animal index 3. What animal is that? Okay, folks, what animal is that? Well, I hope someone said horse. I hope someone thought horse. Okay, so let's go down here. 1, 0, 1, 2, 3. Same thing as horse. What is animal 5? Well, don't do this. Don't go 1, 2, 3, 4, 5. It's the index. In this case, there's the index, and it's going to be a cow. 7 is going to be a lizard. Why do we start at 0? Because think about it. If we didn't have that 0, we're starting at 1. And then we have to go, once we get past 9, we have to add another column. So let's start at 0, not waste the space. Horse, good job. Good job, folks. All right. So it offers us needless repetition. It's like a lot like doing a variable, except you got more members. And instead of, you have this little bracket here, and there's nothing in it. So in the past, it would have been integer LED pins equals 1, and there'd be no bracket. But here there is, and that's saying we're going to assign 0 to, so we got 3, 5, 6, 9, 10, 11. We always said the index starts with 0, so that will be, if we would put 0 here, LED pins 0, the computer would think you're talking about 3. If you had LED pins 1, it'd go to this one here. It would say 5. And that's how the computer would read it. All right. Right. So these squarely brackets are containers. So it's an LED pins. And all these values are in there. And see, there's the containers right here and here. All right. Okay. So you can do things as, can you make your PWM capable of lights breathing? So all of them go on at once. You'll need to use array and multiple loops. I'll give you that tip. So can you figure out a way to get them all at once? Tip, it's going to require an array. Go ahead. Let's get started on this a little bit if you can. A 1, 2, 3D circuit. I would like to get through this array part, and then we'll stop for the night, and then we'll go into hardware next week. Raise your hand when you think you can do this, guys. Okay, folks. How are we coming on this? I've only got 2 hands raised here. Okay, so here's what you're going to try to do. You're going to take that LED pin with the brackets, colon 3, 5, 6, 9, 10, 11. Start at 0, counter less than 6. So what's weird is you're going to use this counter to fill these brackets up. So you can start at 0 to 6. And then what you're going to do is you're going to say pin mode LED pins counter output. So this is going to take, this 0 index refers to 3. 1 refers to 5, 6. All right, so that's going up to 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. This is going from 0 up to 5. Then you go on to this next one. And there you're set. So let me leave the codes up there for you now. All right. So it's getting after 8 here. Can you go from 3 to 11 brighter and then dim 11 to 3? Again, all you're doing is you're setting up a counter, filling it up on that array. There's your void loop. Analog, LED pins, and this is your members of your array. And you're going up and down in value. Now we're using I for integer in this case, something I normally don't like doing. And you can you spell out your phone number? Remember to do that traffic light. The traffic light requires nothing in loops. When we come back next Monday, we're going to be doing electronics. I'll stay on. Does anybody have any questions? I'll leave this code up there for you to look at, okay? Please register on YouTube on that playlist so that way you can stay up with it, all right? All right, we'll start on electronics. Make sure you save it. I don't see any questions. Anybody have any questions? Thanks, and have a good weekend. Thank you very much, sir. I will. Everybody else, any other questions? All right, well, take care, all. Bye-bye.